balancing chemical equations. So in this video, I'm going to show you how I teach balancing chemical equations. It actually, I hate to admit it, took me a while to figure out a good way to teach students because this can be very confusing at first. So I came up with a method of using some terms, drawing out the formulas in a particular manner. So I hope it helps you. If you find that you're able to balance these chemical reactions without drawing the pictures and using my method, then you are more than welcome to use your own method. This is just a way to teach it and hopefully, hopefully have everyone become familiar with balancing chemical equations. So to start off with, we're going to talk about the law of conservation of mass. So the law of conservation of mass dates back to about the 1780s, when we discovered the idea that mass is neither created nor destroyed in chemical reactions. So let's write that down. Mass is neither created nor destroyed in chemical reactions. And so what that really means is that the mass of any one element at the beginning of the reaction will equal the mass of that element at the end of the reaction. So the mass of an element must be equal from beginning to end. And so on this sheet, I have a couple of examples of equations, and we are going to balance these. Before we do that, I want to offer some terminology to help keep things consistent as we talk about these equations. And the word equation is used in here because, as you can see in some of these, it's the idea that we are adding some formulas, some molecules together, and getting some larger formulas or molecules as a result. So it's very similar to a math equation. However, if you'll notice, we don't have an equal sign. Instead, we have this arrow symbol. Okay, so a couple of things. First of all, these are called chemical formulas, and they are showing you kind of like a recipe. They're showing you how many atoms of that particular element is in the molecule. So there's a subscript 2 behind this capital letter H for hydrogen. So that means there are 2 atoms of hydrogen in this one particular molecule. Over here for water, I have the number 2 after the letter H. That means there are 2 atoms of hydrogen. And in the same molecule, there is oxygen, but if you notice there's no number behind the oxygen, that means that there is just 1 atom of oxygen in this particular molecule. So in H2O, I have 2 atoms of hydrogen and 1 atom of oxygen all bonded together in what I call a package. Okay, and there are these lines out front, which is kind of the whole goal of this activity. These are coefficients, and we're going to be putting coefficients in here to represent how many of each molecule we need to actually abide by the law of conservation of mass. And so if we take a look, we have the beginning before we get to an arrow, and these components to the left of that arrow are called reactants. Which kind of makes sense. They are reacting together. Sometimes you only have one reactant, though. Keep that in mind. And then at the end of the arrow, on the right side of the equation, we have what we have actually made in this chemical reaction, which is a product. So I'll put the word product there. And then because they are different from a math equation where we would say equals, we have this arrow, and instead we use the word yields. So I could say H2 plus O2 yields H2O. So just some basic vocabulary that we can use together. And so what I'm going to do is I'll actually start with this equation first. That'll be a good one to practice. I'm going to rewrite it over here, though, so I have a little bit more room to draw. And I'm going to show you how I go about teaching students to balance the chemical equation. So remember, by balancing, I'm trying to make sure that I have equal amounts of each element, so those are the letters, before the reaction and after the reaction. Okay, so in this particular equation, I have two elements, hydrogen and oxygen. So I want to make sure that however many hydrogens I have in the beginning of the reaction, I have the same amount at the end, and same for oxygen. However many I have at the beginning, I have at the end. So the first thing that I tell students is I simply say, let's draw a vertical line where the arrow is. And that helps us to visualize the left side of the reaction and the right side of the reaction, where we're trying to balance. The second thing I recommend doing before we even start thinking about balancing the equation is to actually draw what this is. So this is two atoms of hydrogen. It's like saying H, H, bonded together. And because they're bonded together, we're going to visualize that by drawing a circle around it. I call that a package. These two hydrogen atoms come as a package deal. I can't break that package. I can't take one hydrogen out of the package, then it no longer works. So those two hydrogens have to always go together. Okay, then we're going to draw this particular package. There are two atoms of oxygen. So that's like drawing two O's. And I'm going to put a circle around it. Kind of looks like a pig nostril. And that's going to represent our molecule of oxygen. Over here, I have two atoms of hydrogen, one of oxygen. So I'm going to write it like this. Doesn't really matter. But again, the important part is that I draw a circle around it representing the package. So then I begin the process of balancing the equation. So I want to take a look at what I have on the left versus the right and make sure I even them out. I always start with my first letter on the left, which happens to be hydrogen in this case. There are two hydrogen atoms here on the left side of the equation, and if I look on the right side of the equation, there are also two hydrogens. So that's good. They are equal, and so they are balanced. So let's take a look at our next element. I have two oxygen atoms here on the left side of the equation, but I only have one on the right. That is not balanced, so I have to fix that. Remember, I can't take away from the package, but I can add a package. So I would actually like to add another oxygen over here so that I can balance the number 2. I have to add the entire package though. I cannot just add an oxygen by itself because it's attached to those two hydrogens. So now I have two oxygens on the left and I have two oxygens on the right. That is now balanced. But as you can see, I kind of messed up my hydrogens in the process. So I'm going to backtrack, and I still have two hydrogens over here, but now I have 4 over here. I can't take away, I have to add. So I'm going to add hydrogen over here. I need to add 2 of them, and lucky for me, they actually come in a package of 2. That's awesome. So now I have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens. 1, 2 oxygens, 1, 2 oxygens. Everything is balanced. It's equal on the left and the right. So the very last step is to count how many packages I have and write that number as my coefficient in front of my formula. So I have 2 packages of H2, so I'm going to put a 2 there. I only have 1 package of O2, so I'm going to put a 1 there. And I have 2 packages of water, so I'm going to put a 2 there. This is just a method that I have discovered in teaching balancing chemical equations. It seems to work for students. The great thing about this process, this think pattern, is that once students do it over and over again and get good practice at it, they start to realize that they might not have to draw those pictures at some point, and that's great. Let's take a look at some of these practice problems. So I'm going to start here with this one. I have N2 plus H2 yields NH3. I'm going to draw my line right where that arrow is, and then I'm going to draw my packages. So I have 2 nitrogens together in a package. So I write 2 letter N's and put a circle around it. I have 2 hydrogens in a package. So I'm going to draw 2 H's and put a circle around it. And then my product is NH3. So I'm going to draw an N and 3 H's and put a circle around it. And now I try to begin balancing. I have 2 nitrogens over here. I only have 1 over here. can't take away, so I have to add. So I'm going to add a nitrogen, but I have to add it as a complete package. So now I have 2 nitrogens on the left, 2 nitrogens on the right. I have 2 hydrogens on the left. I actually have 1, 2, 3, 4, 5, 6 on the right. Those are obviously not balanced. I can't take away, I can only add. So I'm going to add over here, and I need to get to 6. I already have 2, and they come in a package of 2. So I just have to add 2 more packages. Now I will say I always go back and double check to make sure that I didn't goof something up in this whole back and forth craziness. So let me double check. 1, 2 nitrogens, 1, 2 nitrogens. 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens. So I put my coefficients in the correct location to show how many of each package I have. Let's take a look at another one. Draw my line. Now I'm going to draw the packages. This is an interesting one here, CH3OH. So I actually have 4 hydrogens. Even though they're not written together in the formula, I'm still going to put them together. It just kind of helps me visualize a little bit better when I need to count. Okay, so in that formula, I have 1 carbon, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens, and 1 oxygen. Okay, now I'll begin the process of balancing. 1 carbon on the left, 1 carbon on the right, 1 oxygen on the left, 1 oxygen on the right, 2 hydrogens on the left, 1, 2, 3, 4 hydrogens on the right. So I need to add 2 more hydrogens to get to 4 on the left. Double check real quick. 1, 1, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4. I have 1 of these, 2 of these, 1 of these. At this point, if you're feeling pretty good, I would recommend that you go ahead and try the last 4 on your own. You can write these on a separate piece of paper and then continue to go through and draw the packages like I have shown you. If you're not feeling so good or you're still having a hard time understanding it, then I would recommend that you continue to watch the video. But at some point, it's always good to kind of test yourself to see how well you can do this on your own. So at any point, feel free to pause the video and keep practicing. I'm going to move on to number 3. I'm going to draw that vertical line. I'm going to draw the packages of elements. And now I'm going to start to balance. I have 1 nitrogen on the left. I have 1 nitrogen on the right. This one's interesting. I have 1, 2, 3 on the left. Even though they're in 2 different packages, I still have to look at them all together because they're all on the left side of the line. So I'm going to add those all together. 1, 2, 3. Over here, I only have 2. So I can't take away, I have to add, so I'm going to add 1 more. And now look what happened. I have 1, 2, 3, and now I went over. I have 1, 2, 3, 4. Now I have to go back over here and I have to add. I only need to add 1. So if you look at my options of adding oxygen, I have this option to add a package of NO, or I have an option of adding OO. It makes sense because I only need 1 more oxygen to add this package with just 1 oxygen. And lo and behold, it actually helps out because in the meantime, I had added a nitrogen over here, so I needed to add 1 over here. So again, we had quite a bit of back and forth, so let's go through and double check. 1, 2 nitrogen, 1, 2 nitrogen, 1, 2, 3, 4 oxygen, 1, 2, 3, 4 oxygen. I have 2 of these, 1 of these, 2 of these. Okay, so again, if you feel brave, you can pause and try to practice some on your own. If you don't, feel free to keep watching. This next one is a little bit different because I always have students who are unsure of this right here. This is actually a capital A, lowercase l, so that represents aluminum. that is not two different elements. So in that case, I would have an A, and I actually like to write mine in cursive so you can see they're connected together as one atom. So I have an aluminum, I have 2 oxygens, and then over here, as you can see, it's Al2. So I have 2 aluminums. I recommend that you write it like this. There's 2 of these aluminums, and then 3 oxygens. Just so you know, it is not an ALL. Okay, because that 2 is after the L, the AL go together, so you have to make sure you write it as ALAL. So let me try to balance this. I have 1 of these, 2 of these, so I'm going to need another aluminum over here. I have 1, 2 oxygen, 1, 2, 3 oxygen. So I need to add over here, but unfortunately, I had to add too many. So I got to go over here and add. And I still have too many oxygen. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Let me fix that. And then let me go back and double check. 1, 2, 1, 2, 3, 4. So I got to come back and do an aluminum and aluminum. So now I have 4 aluminum, 2, 4, 6 oxygen, 1, 2, 3, 4, 5, 6 oxygen. I am going to stop the video at this time, and then I will make a separate video where I show you the answers to number 5 and 6. But I really want you to give 5 and 6 a shot on your own.